Okay, welcome everybody to Go in 5 Minutes, episode 15. Today we're going to talk about the final problem on the trivial concurrency exercises page, and that's going to finish up our concurrency series that you can see in issue number 14. A couple notes before we get started. Just like last screencast, there's an extended screencast that is going to fix a bug that we'll see in the code that we'll present today. Also a reminder, go to this link if you haven't already and subscribe to the Go in 5 Minutes newsletter. So let's get right to it. Today we're going to solve this problem in code, and we're going to touch on two pretty powerful concurrency techniques. One's going to be how to broadcast a signal to multiple Go routines in a really simple and straightforward way. And the other way is going to look at a creative new way that you may not have seen to use the select statement in Go. So let's get right to the code. Close up the README there. And you can see we're just going to start out with some odds and ends, kind of bookkeeping stuff that we're going to need, convenience functions as well that we're going to need in our code. And we'll jump right down to this struct. This is the tourist struct that represents the tourist. It only has a number here, but if you go into the extended screencast, you'll see that there's some more stuff we're going to put in this struct to make it a little bit easier to deal with tourists. We'll go down into our main func. We're going to have two channels to start out with. This is the line of tourists waiting to go use the computers. And this is the channel we'll use to broadcast for all the Go routines that represent the computers to stop waiting for tourists. So then first of all, we've got a for loop that starts up each computer. The computer just has an infinite for loop that either waits to shut down in the select, that's where the broadcast channel is used, or it waits for a new tourist to come in. Once it comes in, it basically just logs and sleeps. That represents the tourist using the computer. And then when it's done sleeping, it just logs again. And that's just per spec in the problem. And then down here, this is where we essentially open the doors to the internet cafe. We create the tourist, we send the tourist down on the queue channel. And in this case, this is our new usage of select. So either we're able to immediately send the tourist down the queue channel, or we're not. And in the case where we're not, that's the default, that's the place where we want to log that the tourist is waiting. But in this case, we don't want to log the tourist is waiting because the tourist will just immediately go start using a computer. So they're not waiting. And then finally, down here, we have a hack. And this hack is basically waiting for all of our Go routines to finish. We've got Go routines that are sending tourists down the queue channel. And then up here, we've got Go routines that are simulating the computers themselves. We want to wait until all the Go routines are done. But in this case, we really don't know how long to wait. We can't calculate that because the tourists are using a random amount of time to essentially call time.sleep. And so we can't know deterministically how long to sleep. So that's why this is a hack. And we'll see, first of all, how this comes in our code. And you can go to this link here for the extended screencast to see how to deterministically fix that. And then finally here in our close, this is broadcasting to all the computers that after all the tourists are done, then all the computers and these Go routines should shut down. And that's represented by the return here. And you can see a little bit more detail in this comment. So let's see this thing in action. We'll just call it make build run. And you can see here, they're all waiting for a turn, but then, the place is empty. Let's close up and go to the beach. Well, what that's saying is that we actually haven't allowed all the tourists to wait their turn and then get to use a computer and then finish using the computer. And that is where this hack comes in. So we're sleeping here for 1 second. Let's increase that to 10 seconds. We'll save that. Let's see what it looks like then. So now we've got some tourists online, some waiting for the turn, just like last time. Now some tourists are starting to be done and new tourists are coming in to use the computer. But if you'll notice, for example, tourist 17, they don't actually finish up. We just close the place up, go to the beach before they're actually done using the computer. So now we're going to have to go in and increase this a little bit more. We'll go to 15. And you can see sort of this non-determinism is starting to creep into our code. So there is a way to sleep the absolute maximum amount of time that all the tourists will take to start using the computer, finish using the computer, and exit out of the Go routine. We can do that, but it's very, very hacky, and it's very, very non-deterministic. So our code will actually be less efficient than it could be if it deterministically stopped running after all the tourists are actually done, and immediately after all the tourists are actually done. So that's it for now. We're actually over time. So I'd encourage you to go check out that extended screencast at this link, gum.co/gifm-x-15. And I'd encourage you to go check out, first of all, how to solve this particular problem. But also, you'll learn about a pattern to solve this entire class of problems to tell when a group of Go routines are done, and after which you can kind of continue on execution of your code or determine when to shut down your program. So that's it for today. I'll encourage you guys to go check out the extended screencast again, and I hope to see you next time. Take care.